So hi everyone, thanks for taking some time off your schedule today to join us to learn more about horizontal form, fill, and seal pouch packaging. Horizontal pouch machine should not be confused with flow wrappers. This is something I will explain. Those machines are typically used for packing granola bars, individual cookies, or other products that can be fed on a conveyor with a cleat. You will recognize there the image, the type of packing. This is not what we're talking about today. And on the right, this is also another type of form, fill, and seal technology that's very common. People sometimes confuse horizontal form, fill, and seal and vertical form, fill, and seal. The vertical baggers are typically used for bags of potato chips, candies, hanged on displays. Of course, there's a lot of other complex bags that can be made on a vertical machine, but the topic is for maybe another webinar. Now you can see the typical film path for a vertical machine. So I assume most of you already pack products into pouches or bags. So whether you are using pre-made pouches, vertical bagger, or an older generation of horizontal bagger, our goal today is to share information and make you dream a little bit about your future opportunity for packing your products. And to do that, we gathered some of the best in the industries. We have three experts. First one is Roberto Travaglini. He's a business development manager for TC Transcontinental Packaging out of Montreal. This is a pretty large supplier of flexible material, both roll stock and pre-made pouches. They have over 28 plants across North America, and they have full service capacity. Okay. Sorry, Roberto will be talking in second. The first one will be Robert Libera. He's the sales manager for PPI Technologies out of Sarasota, Florida. PPI is one of the largest supplier of pouch packaging machinery in North America. And then we will have Olaf Clements. He's the CEO and owner of SN German Pouch Pack Technology, manufacturer of the most advanced horizontal form, fill, and seal machinery on the market. Presentation is intended to be short, only 1 hour with 3 speakers. So we will provide an overview of this amazing packaging technology. Some of the topics we will cover will go from like the main difference between pre-made and form, fill, and seal. The benefits, I guess, of using form, fill, and seal versus pre-made. Potential savings in material and labor associated to that. And also with Roberto for the film, you will explain like the importance, like anything else, to do your homework. Know like your SKUs, the type of products you will pack, the volumes, and all that. It's pretty important. And then finally, Olaf will go into more details for, I guess, the type of bags we can make on a horizontal form, fill, and seal. Those of you who are familiar with the older generation, like the Bartelt or the Bossar, you will see there's a lot more we can do, like spouted pouches, gusset, and complex pouches as well. So we want to keep the conversation going. So we are open to schedule time individually to look closer at your specific projects. At the end, there will be a Q&A session. So you can always, during the presentation, not to forget your question, write it in the chat box. And if we feel we can address it right away, we will do. Otherwise, we'll do it at the end. So without waiting any longer, we'll start with Rob Libera. So I hope you will enjoy.
JF, thanks for the introduction. Appreciate the opportunity to talk to the audience here today. My name's Robert Libera. I'm the sales director at PPI Technologies Group here, situated in Sarasota, Florida, on the west coast of Florida on the Gulf side here. We have a nice facility here where we typically have a lot of machinery. We have 150,000 square foot facility. So if anyone is interested in actually coming, seeing, touching any of this equipment that we're going to chat about today, we do have it on our floor. We can demonstrate it. We can run tests on it with your materials, and we can give you a good feeling for what the machines look like and what to take into account when considering this technology. So in general, we're not going to talk about a huge amount of technical details here today. What we're going to focus on is more what what is a compact horizontal form fill seal machinery? JF went through it a little bit. I'm going to talk about it a bit more in terms of the market segments, who can consider it, and who's a good fit for it, and what you should expect from this type of technology. So in general, I think everyone in the industry who's in pouch packaging at the moment is seeing some of the same challenges with labor, with looking to automate, to try and increase efficiency, and in general just produce more product and pouches than with reduced operator involvement, because people are hard to get to work these days, and there's definitely technology that can help you reduce operator headcounts and automate in general, from pouch packaging all the way through your line. So some of the things that you need to consider with machinery in general is what's the flexibility of it, what's the reliability, and what's the efficiency. Traditionally, form fill seal has been seen as a technology where it's a big machine, it's very high speed, it's a lot of technology, it's hard to set up, and it's hard to run and potentially even maintain. That's not necessarily the case here. SN has launched a whole range of small entry-level compact footprint machinery that gives you high performance, lots of flexibility, and ultimately efficiency. So who could be considered company-wise and or products for this market? Several. Anything from food, snack, confectionery products, nutritional powders and supplements, pharmaceutical products, personal care, unit dose, portion control, and even contract packaging companies, where even though they're looking for a lot of flexibility and multiple changeovers, there's definitely a niche in this market for them too, to produce higher output products on these machines, but still have flexibility for changeover. So some of the things that typically someone wants to consider with a horizontal form fill seal machine is the pouch quality. Typically, JF went over the vertical form fill seal. A lot of people are used to pre-made pouch fill seal equipment, and obviously there you're getting a very high quality pouch. Off a horizontal form fill seal machine, we can still produce a very high quality pouch. We can make it look almost identical to a pre-made, and you can get that quality as well as an uptick in speeds and overall outputs. And again, from compact footprint machinery. So what's some of the goals when wanting to look at form fill seal? Well, typically reducing your operator involvement during a normal production run. So with the form fill seal with roll stock, you can get anywhere upwards from between 10 and 15,000 impressions on a roll. So what does that really do for you? Once you have your machine set up and it's running, you have very little operator involvement in terms of what they have to do. They're not loading materials. They're not constantly touching the machine. So if you look at it that way, you have an operator that's potentially freed up. He still has to monitor the machine for sure, but his actual touching and feeling and handling of the machine is very much reduced. If you look at just a minimum of about a 10,000 impression on a roll, you're looking at roughly about at 50 to 60 pouches per minute, roughly about 240 minutes of operating time off that roll before an operator would really have to change it and go to the next roll. Those roll changeovers are very, very quick, typically around 5 minutes, and you put your next roll on, and you might experience having maybe 2 roll changes throughout a whole shift. So that's really a benefit in terms of running, continuous running, and obviously getting your efficiencies. The types of pouches that can be produced on these machines, anything from a 3 or 4 side seal, sachet style, to a stand-up zipper with press to close feature, or even Velcro. So it offers you a wide variety of different types of pouches that you can produce, as well as obviously flexibility to change. So who are typical candidates for this technology? Normally someone that's running 3 to 4 different SKUs, and roughly anywhere from the 4 to 6 million per SKU. You can really benefit from running horizontal form fill seal machine, getting the benefit of reduced pouch cost, the logistics that are actually go around that, so shipping, all of those things around material suppliers can actually be optimized by getting roll stock, getting your zippers on roll, and really not having to ship a lot of materials backwards and forwards. So also, as far as ideal candidates, typically a company that would do probably no more than one SKU per day on the machine. You could do more, but typically you don't want to be setting up and changing machines over during a shift. So a normal operation would be a single SKU or type of package and or product in one day. And that would also go across the board for as far as your actual clean up on your products, your changeovers, your materials, and stuff like that. The additional benefit with these small entry-level compact machines is their setup time. So, how long does it take to actually get a machine into your facility? These machines, which is we're going to talk about a little bit, is an FME 50 compact footprint, single frame, electrical panel, located in the machine under the belly. You can move it into your facility. You can get it set up in relatively short period of time, normally a day to a couple of days, and you can have the machine up and running production. And speaking from experience, we've installed several of these machines, some of them that are brand new customers going into form full seal, others that have been running traditional pre-made pouches, and they've got into the facilities up, running, and really performing within a matter of days. In addition, a lot of times when people think of form full seal, they think of changeovers as being a major issue. These new machines have a lot of advancements in actual changeover procedures. We have pouch holding grippers that can change automatically with a turn of with a turn wheel. We have side seal frame assemblies that move easily on scribes and to fixed positions. We can do center lining on them, so we can actually have various jigs, and we can actually reduce and limit the amount of operator involvement even in those activities. So what you're seeing on the screen right now is an FME 50 compact footprint machine. Back end of the machine, we're unwinding, we're coming off the roll, we're running through a series of dances there first, and we have a splice table at the back for cutting the roll and roll changes. You're looking at the side seal frames and bottom gusset assembly there, being easily movable, adjustable to fixed positions. We're moving the foam through the side seal, obviously making punch holes, 10 notches. We cut and transfer the pouch into the rotary turret. And at that point in time, it's very typical or similar to what you would see from a typical full seal process. Same process there, open the gusset if there's a gusset, fill the pouch. If there's anything else addition that needs to happen, be it a second fill, taking any type of contamination out the top seal, gas flushing, or anything like that, we can additionally do that. And then if you want to move on to the next slide, Jen. So what you're going to see there is a typical FME 50. That's our compact footprint machine. You have zipper unwind on the roll on the left, on the right rather, and the material unwind on the left. You can keep running it, Jane, so we can go through. Back end is the splice table for quick and easy splices, and then the picture that you're seeing right now, that's our gusset punch for making the stand-up hole, and that's where your true stand-up pouch comes from. Feeding it over the plow, tucking in the bottom gusset at that point for a stand-up pouch. Obviously, if we just have a four-side seal pouch, we're not going to do that at that point. We're sealing in the zipper. We'll crush the zipper side seal as well. We're back onto the back end of the machine there to the zipper unwind. We feed it under limited tension and through a couple of dancer bars. And then obviously again back to zipper and side seal assemblies. For finishing, we have top seal, top tear notch and hole punch, hanger hole that everyone's familiar with. We feed it through servo feed rolls, and then we cut and transfer into our rotary turret at that point. The pouch holding grippers that you're looking at there, those are automatically adjustable from a turn wheel and can be adjusted without format parts to different pouch sizes. Image you're looking at there is bottom gusset forming and opening, top opening by vacuum. So we open the top of the pouch, we form and open the gusset, and then depending on the filling method, we will dive in with diving duck bills at that point, or if it's an auger, we'll have an auger sitting at that position. We then stretch the pouch after filling prior to the top seal that you see there. So we have control of it, we stretch it, we get a nice flat top seal, and then we come in and seal the top closed. And then pick off for discharge. Top seal assemblies can rotate out and to an easily accessible position where you can clean it, you can replace tooling, etc. If you could move on to the next slide then, Jane. What you're looking at there, entry level compact footprint machines. At the other end of the spectrum, which what most people are probably familiar with horizontal form fill seal, we also do the very high end. We do the high speed 120, 150, all the way up to 400 and above in terms of output. So what you're looking at there is a hygienic series of machines. These are open architecture, sanitary design, typically in high washdown environments, meat, cheese, etc. And these are machines with very high output, a lot more sophisticated, and obviously types of pouches and speeds that they're running, different in terms of changeovers. But that's just to give you an idea of the two ends of the spectrum. Typically what we had wanted to discuss, at least from my portion today, was a compact entry-level machine that you can look at transitioning into your facility, slightly higher output where we can achieve run speeds of anywhere from 50 to 70 and maybe above, depending on the product rather, and then easy changeovers, repeatability, reduction in operator and staffing, as well as your reduction in overall pouch costs through savings in materials. And I think that's about all I have time for. I'm looking here and I have got through it with 30 seconds to spare, Jen.
Awesome work, Robert. Thank you so much. I'm going to pass the microphone on now to our friend Roberto Travaglini.
Yes, thank you, Genevieve. Can you hear me?
Yes, I can hear you.
Okay, great. Well, thanks, Genevieve and JF, for having me here. It's a pleasure to be with you guys. I'm going to talk a little bit about mostly roll stock films. And everything I'm going to talk about is a little bit in general because obviously every situation is different, every product is different, depending on the size of your packaging, what are you packaging, etc. So we're going to look a little bit at the film structures and the things that you can have versus stand-up pouches. We are then going to look at the considerations that you have to take into account for taking a stand-up pouch and going to a roll stock. And then we're going to talk a little bit about recycle-ready structures. So quick glance at TC. TC Transcontinental is a Canadian company based here in Montreal. We started in the printing business in 1976 and transitioned. We are still the largest commercial printer in Canada today. But in 2014, we started transitioning and getting into food packaging, plastic packaging, which was a business which was very similar to the print business. Just the only thing that we were doing different is printing on a different substrate. Instead of paper, we're printing on plastic. So you can see a little bit the companies that we've acquired since 2014. And right now we're up to 28 production facilities, of which 21 are in North America. And then we have 7 other worldwide, as you can see, New Zealand, Guatemala, Colombia, Ecuador, and the United Kingdom. You can go to the next slide, Genevieve. So what are the film structures and the savings that you have to take into consideration? If we look at, I'm giving you quite a big range here. If you take a roll stock versus a stand-up pouch, you can pay anywhere from 20 to 40% less for the roll stock than a stand-up pouch. So that's something that is quite important. But before we do that, you need to determine what your needs are. How big is your pouch? How many SKUs do you have? What are you packaging? What is the speed that you normally would go with a stand-up pouch versus a roll stock? Those are all questions that you have to ask before you can determine which one is more beneficial for you. And you have to also determine the film compatibility of a horizontal form fill machine. Most films on a horizontal form fill machine will work well, but there may be others that are so finicky that for whatever reason, they just don't work well. So that's just something that you have to take into consideration. I'm not saying that it will not work. I just say it's something that you have to consider when you're making your decision. So some of the considerations that you have to take into account if you're trying to transition a stand-up pouch to a roll stock. Robert even mentioned this, is typically horizontal form fill machines were usually beneficial for longer runs. As you will see from even the presentation that Olaf will present, is that's no longer the case. The machines are much smaller, they're compact, the changeovers are very quick, but you still have to consider what you had as stand-up pouch, what you're going to use as a roll stock. So those are considerations that are very important. One of the features with stand-up pouches is you end up getting no waste because the pouches that you get are all going to be good, and the waste is already included in your purchase. But like I said before, 20 to 40%, there could be a consideration for you to go to roll stock versus a stand-up pouch. What you also have to take into consideration is, when you're going to have a horizontal form fill machine, you have to do trials. So what is the cost of those trials? You will need new graphics, you will need new plates. So that's an obvious that, you have to consider as part of the cost of transitioning. How large will the roll stock be for a horizontal form fill machine? You can still go back to the other Genevieve. There we go. And can your operators handle these large rolls? Robert mentioned that you can have rolls that will last up to 4 hours on your machine. So that's good. It might be getting a hoist to lift these big rolls. So you put them on your machine and the machine will run for 4 hours. So those are all little points that you have to consider when you think about going from a stand-up pouch to a roll stock. And you basically have to do a table. What are the pros, what are the cons? And like I said before, it all depends on what you're packaging, the size of your current package, etc. So you can go to the next slide, Genevieve. So then recycle ready structures. We all know that in Europe, the recyclable materials that are available, they're a little more advanced than we are here in Canada, and more advanced than the materials that you find in the US. We are currently producing a lot of recyclable materials at TC right now. But what we really have to figure out is what is truly recyclable in Canada. And right now, that is a little limited. What's very, very interesting is anything that is a polyethylene based is easily recyclable. And what is not, it is recyclable, but it doesn't mean that it's actually being recycled. So something that's very important to remember. And sometimes the recycle ready materials have smaller operating windows than regular materials. And by that, I mean the temperatures that you're going to seal these materials with are going to be lower, but they're not going to be as wide. So let's say you have a, 20, 30 degree operating window with a regular material, you might only have a 15 degree operating window with recycled materials because they're a lot softer. So you have to be a little more careful. One of the structures that we use constantly is a structure that is 96 gauge BOPE to a 2.5 mil HDPE. What's interesting about this is that we always keep the outside structure basically the same. So this is basically your print web. So it's reverse printed. And then the HDPE, we can make that as thick or as thin as you want. We can put it with or without barrier. And the barrier is usually an EVOH with a compartmentalizer in it. And that allows you to be able to recycle it. And that structure that you see on your screen right now is actually considered a recyclable number 2 structure, which is very interesting. So it's relatively easy to recycle. And you can put it basically in your recycle bin and it should be able to recycle. So one of the advantages of this BOPE is it's a lot more heat resistant than a regular PE. And that's why we use it as what we call the abuse layer, which is the outside layer in the lamination. Even when we make our own pre-made stand-up pouches for recycle ready materials, this is the structure that we use because it allows us to put more heat on it and actually make a pouch that looks decent and not all warped. So those are basically in a really quick overview, some of the benefits or maybe some of the points that you have to remember when you're trying to consider transitioning from a stand-up pouch to a roll stock for a horizontal form fill machine. I think that's all I have for now, Genevieve.
Thank you very much, Robert. I believe that, Roberto, I believe we have a question from Fadi. I'm just going to allow the microphone from Fadi Rabath. I believe that's your name. Fadi?
Yes. Yes. Hello, Roberto. How are you?
Good, yourself?
Very good. Thank you. Hi, everybody. So, I have a few questions that came to my mind because I'm working on a few projects like that. So, I mean, I have a customer in a concrete, solution, a concrete business case. He has one SKU that is like around 1.2 million to do, and the other ones are less than 200,000 SKU. Is it reasonable to think, making a horizontal form field seal machine? What will be the minimum quantity to go to rolls? I would like to have your input on that, if possible. The second question I have is in the food business. I don't know if we have a structure that could be recyclable in Canada, or that we can say that it's recyclable. If I'm wrong, I need to know about it because it will be beneficial to get this pouch on the market and push the
Yeah.
customers to.
Okay. Okay. To answer your first question, it all depends on the size of your pouch, but we've done runs of 50,000 impressions. It all depends. What we do is we usually have a minimum that we calculate, and it goes by square inch. Obviously, I can't tell you what that is, because it is kind of proprietary. But it is like we've done, like if you have a standard stand-up pouch, like I don't know, that's 7 inches by 10 inches high and a 2 or 3 inch gusset, 50,000 impressions would be our minimum. So it meets the minimum that you were saying, that if you have some SKUs that have 200,000. The structures that I mentioned right here on the screen are recyclable, number 2, and they are recyclable in Canada. That goes without a doubt. They've been certified. You can put them in your blue bin, what we call the blue bin here in Quebec, and it would be recycled. We actually even have our own recycling plant in Ville d'Anjou in the east end of Montreal, where we actually collect all this polyethylene, wash it the best of our ability, reconvert it into pellets, and then we reblow the films and use it as PCR, post-consumer recycled materials, non-food contact. But sometimes what we do is we put it in between. So if you have a polyethylene, let's say that's 3 mil thick, we can go up to anywhere from 30 to 50% of PCR, depending again on the product and the application. And we can actually use it for food grade applications, because the PCR is actually in the middle and it will not touch the food, and it will not migrate to the part where it's actually touching the food.
So, okay, so all the recyclable labeled material or recycling material inside the existing one are multi-structure.
Yes, it would be a 2-layer. It's a 2-layer and it's a number 2.
Okay, it's the same material, but it's 2 layers.
Yeah, it's 2 layers. Yeah, the adhesives that we use, we have to use special adhesives and all that. And like I said, even with barrier, usually anything that has a barrier is not recyclable, but the technology has changed. Like Dow Chemicals came out with a technology about 4 years ago where you can actually put some EVOH. You can't put more than a certain amount. It's actually 4% or less. And then your materials actually become recyclable.
So you have some applications where you have used it for fresh foods that you can put it and preserve it for a longer time.
Yeah, absolutely. You can gas flush it. Yeah, you can gas flush it as well too.
And it's recyclable. Very good.
Yes.
I would like to know more. We'll take it for another call.
Sure.
Thank you very much.
You're welcome.
Thank you.
Okay, thank you for your question, Fadi. Thank you, Roberto, for answering that question.
No problem.
We will now move on to Mr. Olaf Clements, who will present his portion of the presentation.
Thank you, Jen. My name is Olaf Clements. I'm the CEO of HFFS Machinery. We're located here in Germany, in the center of Europe. Having a very good running business with our horizontal form fill and seal machines, which is based on more than 100 years of experience in this field. It started many, many years ago with first paper bags, which are actually also recyclable structures, or it's a recyclable structure today as well. and then it moves into multi-layer laminates, and nowadays we're moving back into or mono type of materials like Roberto mentioned before. Fadi, maybe a quick comment to the discussion before. Of course, Roberto gave us a recommendation from which point on it makes sense to print film for roll stock. We have from our machine or building aspect and of our cost structure of the machines, Jan estimates that we are saying, okay, you might or should produce at least 2 million pouches on a small form fill and seal machine that you can justify it. At the end, it's always machine cost per produced pouch, and from 2 million pouches up, matter 3 or 4 million pouches, you are going really in an efficient way, so that your cost aspect is also very positive and economically. That only as a comment, and maybe in the Q&As we can discuss a little bit more about it. So my talk is a little bit about 5 major points where I would like to introduce a little bit what does it mean to make a pouch, how difficult it is in compared to using a pre-made pouch. Then secondly, which kind of different pouch styles, geometrics we can do, or in the third theme, or what do we have for complexity? So that means which functions we can bring onto the pouch, the limitations and opportunities, and finally, of course, sustainability, which is in our daily discussion here in SN as well. So Jen, maybe go to the next one. That's fine, thank you. So this schematic is showing you what actually is happening in a form fill and seal machine. Actually, you're loading a roll of printed film material into our unwind section, and printed material means that the minimum printing which we need to have is a registration mark on it for the or pouch width, so that the machine can recognize we would like to feed 6-inch or 152 millimeter of film per cycle. So we wind it from the roll down over a couple tension bars to keep the tension very even in the pouch, running it over that film folding triangle very on the right hand side, we call it plow. Then after the plow, there's typically the section where we're printing the pouches. So you would like to have that date code on it, and on a straight film, which a defined speed, it's very easily to print with an inkjet printer, thermal transfer printer, a date code, a lot number, a QR code, or something like this onto it. Depending on the execution and the size of the machine, we are feeding in a zipper profile as an example. And then the main step is the sealing station, which is actually done in 3 steps. Typically, we are starting with the bottom sealing, where we seal the contour of a stand-up pouch. For example, with 2 different contours, the K seal, which is more or less a delta seal, or a Doipac seal, where you have a round bottom. And then it goes into the vertical seals, where you're doing the side seals, or top to bottom, 1 or twice, or depending on the material and the thickness of the material. And finally, we recommend to have a cooling so that we can cool down the hot seals or define to a certain temperature at a certain pressure to get the polymer structure or really fixed in position so that we can feed it further. From there, it goes into our cutting station, where we separate the pouch from the string into an individual pouch, feeding it into our rotary or turret section where we grip the pouch right and left, or in our case, most likely with 8 rotary stations. Number 1 is feeding the pouch in, number 2 opening, third station is where we are diving into the pouch with the plunger, opening the gusset, checking if the pouch is okay, ready to fill, and good opened. Then on station 4, 5, and 6, we have the opportunity to fill in different products. For example, a powder plus a multi-head component like a noodle, a rice, or an oatmeal. And for example, on station 6, or a nitrogen gas flush, or even only small chocolate bits. Yeah? Finally, making a closing on station number 7 and release the pouch over a discharge conveyor to the end-of-line packaging, which could be fully automated on a higher speed machine, but on a smaller machine, or which means if you're operating between 30 and 80 pouches per minute, most likely most of our customers have a hand packing behind a round table and something like this. So Jen, maybe go to the next slide. So of course, what is necessary or to prepare a high quality pouch, it's first of all that we need to unwind the material properly from the roll and keep very precise film tension, and that needs to be under control. Why? The film is a little bit soft, and as more tension you bring on the film, as more differences or you can generate and tolerances. So it's very essentially to control the film tension. And that is on a recyclable monostructure even more important than on a typical common structure from laminates. Then, of course, the quality aspect is also that the top edge of the pouch, the back side and the front side are very even, so that the back side is not sticking up a quarter inch or 4 or 5 millimeters like this. So we are talking from very, very precise adjustment of the top edge, which the machine is operating or with a device themselves. Very important. And once it comes to the pouch sealing, I believe that is one of our major core competences, that we get a super controlled temperature flow. That means everywhere on the seal jaw, we have a very even temperature and not a variation from a couple 10 degrees, something like this. This has worked with older structures where you have a polyester outside and maybe a polyethylene inside. If you have a monofilm structure, of course, we have a small temperature window where we can operate the machine properly, which means from 20 to 30 degree F4, we have to be very precisely there. We can control the sealing time, the sealing pressure, and the temperature. That is very essentially to have a safe process in the pouch making aspect. Yeah? If we have these points under control, the pouch looks almost identically to a pre-made pouch, which you can buy at your converters and so on. And we see it very often that, of course, we have customers which operate on the one hand or from a pre-made pouch machine, and they're just in the changing process to form full seal, and that parallel, more or less the same pouch with the same artwork and the same SKU is produced on both models and both machines, and the final customer do not like to see a difference from the one and the other, and that is another core competence from SN here as well. With the new film structures and running at higher speeds, of course, we developed a technology to seal the side seal twice, and that is a major The major advantage also in compared to a typical vertical machine where the film is running from top to bottom. There you have very normal, only one time seal inside. We can seal it twice, the same seal. That means we can bring the temperature a little bit more controlled into the seal. We do not need to overseal so that we can seal it together. That is important, with a double seal and cooling. And of course, we always talk from slightly tolerances during or inside the film from maybe 1/10 of a millimeter or even less. But that is adding up, and so we can adjust the complete sealing block with the bottom seals, the side seals, and the cooling, right to left according to the position of the iMac, and that brings you absolutely top quality to your product. Of course, what is always important if you're producing, for example, a stand-up pouch with a zipper material, that the material combination from the zipper and the film must fit together from the melting point. So it's an important experience and also discussion with your film supplier and with your zipper supplier, which kind of sealant layer are you using, and that we are more or less at similar melting points. And if that is given, of course, we're able to generate a very nicely sealed pouch. Then move ahead. So we gave you a couple examples here, which kind of pouches we can do. On the very left-hand side, you see a standard stand-up pouch with shredded cheese, for example, that is very common in the market for 8, 12, 16 ounces or even more. Then we're producing on these FME50 machines, for example, very often also only 3-side or 4-side seal bags that we use for typical or savory products or spice mixers, salts, and so on. The machine is able to run there up to 100 cycles per minute very quickly. We can make pouches with a corner spout or with a center spout, like you see more in the middle. The center spout applications are typically for fruit purees and for yogurts. Or we are producing only empty pouches where you can fill an existing, for example, guala pack with. And so you're having up to 50% saving on the ready pouches as well there. And of course, the range is big. There are plenty of opportunities. And talk to us, talk to Rob and Roberto. We're happy to consult you in the executions there as well. So Jen, to the next one, please. Yeah, of course, we have a lot of possibilities to produce these pouches. A typical zipper is well known, it's a reclosable functionality to the pouch. A little bit more advanced is that Velcro style of reclosable functionality. Of course, there's some more material used than on a typical small zipper, that is maybe a little bit less sustainable, but it has much easier functionalities to reclose the pouch. Of course, round corner punches in the bottom or in the top are making the pouch much smoother to look at, gives a little bit better style, looks maybe a little more quality-like. We can cut really a string of material between two pouches out so that you have very smooth corners inside. Also a little bit special thing. Tear notches, any kind, like a diamond type or a triangle type, or only a slip, a cut, are easy possible, as well as different types of hanger holes, only a round corner punch. for example, 8 millimeter in diameter, or sombreros or triangle punches. All that is possible to implement into any of these machines. Okay. Go to the next one, please. Yeah, we're talking now a little bit about opportunities and limitations. I would like to start with the limitations first. Of course, on a form fulfilled process, there's always the aim and the fight between output and flexibility. If you like to have, for example, a 360-degree contour, like an apple or a banana or something like this, of course, everything is possible. It makes no sense to do it on a form fulfill machine because you punch too much material away. It's a little bit complex and so on. Also, if we're talking about bigger formats, bigger pouches, I would say very common are pouches from, let's say, 300 millimeter width, close to 12 inches by 350 millimeter length, 14 inches plus gusset. Up to there, we can produce almost any speed you need on the different models we have. If it goes to a bigger pouch, let's say 400 by 600 millimeter, that is out of the standard range, and yeah, we can discuss solutions as well. Typically, for a small machine like the FME50, we are talking pouch widths from 2 inches, which is roughly 50 millimeter, to around about 7 or 7.5 inch widths and 10-inch length approximately. So that is a typical range we would like to do there. From the operating speed, of course, we can operate a machine like this only with 10 cycles, but it makes economically, in our opinion, no sense, because the investment of the equipment is a little bit more than on an entrance level or pre-made pouch machine. And yeah, and we need to run 20, 30 cycles per minute to justify that investment. And finally, in the limitations, of course, a lot of customers which are used to run more or less on pre-made pouches, they all are scared to make the pouches themselves because of operator skills. But we can take this part away. It's easy to operate such a small machine. The opportunities, of course, lower operator cost. We need roughly in a shift 5 to 10 minutes, depending on the role changes, only to change the roles. That means, the rest, the other 470 minutes of a shift, the operator can take care about quality aspects, or he can look into the material flow, and of course, that is a major part in savings. We can operate at much higher speeds or cycle speeds than on a pre-made pouch machine. That is also a major advantage. It's not big from footprint, and of course savings in material cost. Then move a little bit ahead and go once more. I'm jumping a little bit forward so that we have a little bit time for Q&As. What we are doing here in SN is really, we are testing every day in our test center different film structures. And over the last 2 or 3 years, I would say at least 100, 150 different sustainable recyclable film structures, from mono PE over mono PP materials, paper materials. And we have such a big experience there in handling these different kind of materials, and can exactly monitor what is necessary in our machines to set up to run such a softer kind of material smoothly through the line. You see the upper graph and the lower graph are showing the same material with different setup of the equipment. And with that knowledge, we can transport it back even to your almost installed machine at your facilities and can test and pre-test here, so give you recommendations that the equipment is running properly later as well. So, and what I'm saying with that as well, if you invest into such a even entrance level machine like an FME50, it's still future ready. The machine is made for running also recyclable structures, which we maybe even not know today. Of course, as I mentioned before, we are testing all these different materials, or we have a big database about this. And what Roberto also mentioned before, we see barriers, different barriers also in these recyclable structures like EVOH or SOX or ALOX, where we have very thin layer of material inside and can generate or humidity or barrier inside, a UV light barrier or gas tightness and so on, and still recyclable, but that is in every single country a little bit different under the regulations. So Jen, next one. Of course, for these who are interested in this, spouted pouches in our focus also moving ahead. It's a growing market for us. And of course, while we're talking about recyclable materials, it's immediately coming back to the question, is a recyclable material also possible with a spout? And yes, it is. We have tested also here different materials. It's even more important that the spout material fits to the film material, but we have with our database and experience and cooperations with the film suppliers very good results in sealing these more complex plastic spouts also to the films, having similar output ranges like on the common products and the same shelf lives. So I would say, Jen, I'm almost through with my short presentation here. And thank you for everybody to listen to it. Now we should move a little bit into the Q&A sessions, right?
Absolutely. Thank you so much, Olaf, for all of that information. I'm going to allow now, if anybody has any questions pertaining to any of these presentations, to go ahead and let your question be known. You can do it through the chat, or you can put up your hand and I will enable your mic.
So, of course, I like talking a little bit. Yeah, important point beside deciding for a piece of equipment and buying it is, of course, starting at the point of the commissioning. And if we're talking about a machine like this, we can commission it from arriving at the plant to running the first products within 1 day. Yeah, that is more or less a plug and play functionality. If we're going into a much bigger line, then it takes much longer. But the FME50, which we discussed a lot of, I have seen a lot of installations which were done, first of all, by the customer itself. Secondly, if we support it within 1 day from arriving to first production. And of course, training is essentially, we're having good online trainings for this machine as well, but also support and remote support, which is very common today in a teamwork in between PPI and us.
I believe we have a question from Fadi. Once again, I will allow the microphone. Go ahead, Fadi.
Hi, Olaf. How are you?
I'm doing good, thanks.
Thank you. Sorry, I was interrupted during the meeting, so your presentation. So I got a couple of times interrupted. I'm not sure if you mentioned that, but I wanted to I've installed the machine at Kraft Foods 10, 15 years ago to replace another machine. And at that time, we had a lot of, learning to do and a lot of setups, and it was not that easy at that time. Could you give me, in a nutshell, what are a couple of changes to the design that helped the startup to be faster and smoother? Another point, I see that you're doing a lot of different materials and recycled materials. So my question to you is, do we need to change the sealing bars and different, because sometimes different products need different type of thing. So are you going to supply the recommendations to the film dimensions, to the film sealing elements? What are your implications other than just providing the equipment? Thank you.
Yeah, sure. Buddy, I'm not 100% sure out of my memory. Was that a duplex or triplex machine? At Kraft?
At least duplex. It was the beginning of the triplex that we wanted to put 180, but I don't think we put the 181. It was not, maybe it was the beginning of the 180. I think we had 120.
Actually, we have different sizes of machines. And if we're talking about a triplex machine like this, of course, an installation is taking more time. And of course, on a multi-lane machine, which is doing 2, 3, 4, or 5 pouches at one step, you have to operate, of course, much more precisely than on a simplex machine. On that small FME 50 machine, it has maybe 6, 7, 8 pouches in between the sealing station to the knife station. It's for giving everything there. So that is why this machine is so easy to operate and, let's say, less sensitive against tolerances. If it comes to the bigger machines today, of course, we are using significantly more technology than 10 years ago to keep control under the film's tension, where the sealing jaws are, how to open it, and so on. These are 3 generations further than the machine we discussed or you mentioned before. If it comes to recyclable film structures for an existing machine, I can only say, together with TC, we spent the last 2 days here at our plant and tested, for example, different cheese materials on the recyclable structures. And we figured out also for that what is necessary to change on existing machines that these structures are running on it. And that starts, for example, at different kind of spot sealers, understanding really the right sealing pressures, which we can set up here and determine what is the right pressure to have. Then the right sealing time, which is also important, or at a certain speed. And of course, the even temperature flow over the jaw. And if we're looking into an older machine, you see different areas on that vertical machine, which are hotter than other areas. And there we have a lot of technology to make the temperature flow from bottom to top much more even, let's say in a window from plus minus 5 degrees, something like this. And there I name only insulator plates behind, use of different kind of materials like a bronze material, using in heat pipes. And of course, if that is even not enough, we can switch over to our digital seal technology, which we are developing together with the company Baton. Okay. That answering your question a little?
Thank you very much. Yes. Yes.
Sure. In detail, we can discuss later as well.
Thank you.
Thank you for that question, Fadi. I have put up the email addresses for every one of the panelists today. So if anyone would like to reach out directly to continue the conversation, please go ahead and note that down. I'll be sending everybody a transcript of today's session as well, so you can refer back to it should you have any questions. We still have a few minutes, I believe, if anybody would like to have a question answered.
I think Roberto had to leave, but I had a question, like a chicken or an egg kind of question. If somebody has a new project, is he better off to start with the machinery people or with the film people? Maybe Rob or Olaf, you want to comment on that?
Yeah, I like to step in. Yeah, I would say if that is a very new project, and probably the customer is not super experienced with this, I believe it's a good idea to have first of all a discussion which kind of package do I like to make, which kind of product you have to fill in. And of course, we have a good comparison within all these products we are filling, and we can find a good model for it, but also develop the process. And the process means not only how to make a pouch, also which product we have to fill in, how is it to fill, and which run speeds, and so on. And then, of course, it's always good at this point, while we are understanding what is that for a product, to pull then the technology specialist from TC, from the film supplier, or inside, because when it comes to the point of barriers, gas tightness, and so on, then of course we are not anymore into our 100% comfort zone. Then we should really talk with the specialist on the film, and they can consult perfectly. And if that is coming after we have a certain understanding of the film structure as well, maybe we need to do slightly adjustments on our sealing technology, but these are only minor changes in super details. So I see very often that new customers with a new product are coming more to people like Rob Libera from PPI or us at SN to discuss first, and then we involved over the project the film people and the SIPA people into the discussions. For existing projects or for existing products, they have very often good film structures, and then we're in a different discussion there.
Olaf?
Also, I'll add a little bit to that, JF. I think obviously when you can get all the partners and the suppliers on the same page early on in the process, that definitely helps for a successful rollout of a product. So not only in terms of the pouch design and style, but also what characteristics it has to fulfill, how's it opened, how's it sealed, reclosed, what the shelf life is, and all of that. And that's becoming more and more important now with all the sustainable materials and that, because it's not only the customer that's driving that, they have to put their product into the supply chain, and you've got the retailers that are demanding and saying what types of packages they want in their stores, and they're driving that a lot in terms of the pouch materials, the styles, etc. So Olaf went through it a little bit and didn't have a lot of time to talk about his test machine, but that's a huge resource that customers can take advantage of by supplying materials, by getting different films sent to them that they can test, that they can actually look at what the performance of that material is, and give feedback to to the material suppliers and say, yes, this ran well, or no, the seal window was just too tight. Maybe if there's a little bit of adjustment here, or this is what we have to do in order to work with this particular material, they can give really accurate and positive feedback to not only the client, the customer, but then also to the film supplier that can use that to produce a better material for the actual product itself. So I think it's definitely a good collaboration between the suppliers, and that's an excellent resource. As Olaf mentioned, we have been running tests there. They've tested probably 100, 150 different materials, and they've got knowledge backed up on that, but also they can test new materials as they come in for performance. And it's not just looking at it; they have the data and the printout and points they can measure it. Exactly.
Yeah, and of course, over a wide range of film suppliers as well. But what you mentioned before, once it comes to a little bit more dedicated package, like a stand-up pouch where you seal in or a zipper, then it's essentially that's a zipper material and the film material talk nicely to each other or function nicely to each other. If it comes into the next level, that means you need a spout and a film and a machine, then it's very important that we're talking right from the beginning about the right fit and making all the test for it, that the success of the complete project is really supported.
Okay, great. Jen, do you know if we have other questions?
There don't seem to be any other questions, and we're actually quite few of us left.
Yes, we can go on all afternoon, but maybe we conclude, and we thank everybody for helping in putting this together, their contribution, and also the guest. So hopefully we can keep the conversation going for your projects.
Absolutely. I see Jamie is typing, so let's just give him a second. If you all have
Thanks,
a
Jamie.
few seconds. Oh, it says really great session, everyone. Thanks again. All right, so I guess we're done. I would like to thank all our guest speakers and experts for their knowledgeable presentations. And thank you, all of you, for bearing with us for this first webinar. There were a few hiccups. Thank you for your patience. And I hope you all have a great rest of your day.
Thank you very much, Jen, also for organizing and let us speak and for the invitation here.
Yeah, thanks, Jen. Appreciate the opportunity, and thank you for everyone who signed on to listen to us. And if there's any more questions in the future that pop up, or anything that didn't come up right now, or you didn't think about it, please just reach out via email or get in touch with Jen, and she can make more contact details available, and we'll be happy to answer any of your questions. And then one final thing, if anyone is in the general area would want to come down to our facility to see any of this machinery or technology that we discussed today, we do have multiple pieces of equipment on our floor, and we'd be happy to demonstrate it to you in person.
Awesome. Thank you all again.